Alright, this video is about the circle and the parabola defined in a different way than what we saw back in Tech Math 1. Alright, so the circle is really simple. Here's the standard form for a circle, or an example of something that's in standard form. All we need to do is look at this, and from this we can determine what the center of the circle is. The center is always the opposite of these values inside of the parentheses. So we have -5. Our x-coordinate will be +5. We have +2, so the y-coordinate will be -2, right? So opposite. And then the radius is always the square root of whatever number's over here, right? So whatever number's on the other side of the equation. The square root of 16 is 4. So you plot your center if you want to make a graph. 1, 2, 3, 4, 5, down 2. There's your center. And then use your radius to count away from your center in all directions, left, right, up, and down. So I'm going to count 4 units. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then make a circle. All right, now with the parabolas, we studied parabolas that have x squared in them in the past, right? In Tech Math 1. And do you remember if it was negative in front of the x squared? If we solved for y, right? If it was negative in front of the x squared, it would open down. If it were positive, it would open up. All that good stuff. We're going to look at this in a little bit of a different way. And also look at what happens when you have y squared. So we are focusing specifically on parabolas that have a vertex at the origin. And if you look at the guided notes for this, it'd be a good idea definitely for this. This box describes the standard form that these are all in, and then finding a p-value and what that p-value tells you about the graph. So I'm about to start talking about finding this p-value, and it's all based off of this, okay? To get your p-value, that's what you want to start off by doing. It's always just whatever number is in the problem here divided by 4. So our p-value for this one is 2. What that tells you is actually, in this case, since this is a positive, it's a y squared, and this is positive, the parabola is going to open to the right. So if it's a y squared parabola, it's always going to either open up right or open up left. If the p-value is positive, it opens to the right. The 2 actually is going to give us what we call our focus. So our vertex is going to be at the origin. Like I said, all of these will have a vertex at the origin. We're going to count out 2 in this direction, since our parabola opens to the right, and put a point there. That's the focus. So our focus is 2, 0. They also want you to define a directrix, which is going to always be the opposite, going in the opposite direction, and making a line out of it. So make a dashed line. So the directrix in this case is x equals -2. And we know the parabola is going to open like this. Now here's the important part, I think, especially when your homework had asked you to graph these. If you happen to double the p-value, so what do you get if you double the p-value? You get 4, right? If you work off of your focus, if you count 1, 2, 3, 4 up, and 1, 2, 3, 4 down, that will give you 2 additional points that are on your parabola. Okay? All right. Let's do another one. We'll find our p-value first. -16 divided by 4 is -4. And since this is an x squared, the parabola either opens up or down. When p is negative, it opens down. So our vertex is at the origin again. It's going to open down, so our focus will be -4 going down, right? 1, 2, 3, 4 units down, that'll be our focus. Our directrix, 1, 2, 3, will be 4 units up then. It's going to be a dashed line. So the focus is at 0, -4. The directrix is at